So that all occurred in prophase 1 of meiosis. Now let's look at metaphase. What occurs during metaphase? Well, each chromosome pair meets along the middle of the cell. So I have that already set up. Now remember, the first division of meiosis, or meiosis 1, is when you actually have, at the end of it, half the number of chromosomes. So, during anaphase, number 1, of meiosis, the spindle fibers that come out from the centrosome start pulling away each chromosome pair to opposite sides of the cell. This cell is then going to divide during telophase, and what you end up with are two different cells with the number of chromosomes halved from the beginning. That is the first stage or division of meiosis, meiosis 1. What you're looking at are the two daughter cells that were produced during meiosis 1. Now these cells are going to go straight into meiosis 2, and therefore they're going to skip interphase, where we saw the DNA replicating. So that doesn't happen now. But we are going to have other centrosomes that were in the cell already. So during prophase 2 now, because we're looking at meiosis 2, this is prophase 2, and what happens is these centrosomes go to opposite poles of the cell, which we remember from before. Now this is going to look a lot like mitosis. So the second division of meiosis, so meiosis 2, looks a lot like mitosis. Now this is metaphase 2. And the chromosomes in each cell are going to line up along the middle. So here we have 2 chromatids, and here we have 2 chromatids. And they've lined up in the middle. Now, at anaphase 2, the chromatids are going to break at the centromeres, and the spindle fibers that come out from the centrosomes are going to pull each chromatid apart. So they're going to go to each pole of the cell, and this other cell is going to have the same thing happen. The chromatids are going to break at the centromere and be pulled to each end of the cell. During telophase 2, each of these cells is now going to divide into 2 again. So I'm going to put a line here representing that. And cytokinesis is going to occur, and you're going to end up with 4 cells now. So what we end up with are these 4 cells that were produced over the course of all of meiosis, so meiosis 1 and meiosis 2. Now these would be gametes. So think of the beginning as being the parent sperm cell. Well, now it's divided into 4 daughter cells. And if you look at the genetic material, it started as diploid, and now each of these cells is haploid. It doesn't have its homologous chromosome inside the cell. The homologous chromosomes have been divided up, 1 into each cell. Also, if we look at these two here, crossing over had occurred, which means we have different genetic material that is unique to these sperm cells. And it's this variation that happened during crossing over that accounts for the variation we see. Even though two parents are the same, their kids look very different. Thank you for joining me on this journey as we've learned about mitosis and meiosis. I know these videos will go down in history, and they're the kinds of videos that bring us closer together. So I encourage you to watch these at Christmas and other times when your family is together. Goodbye and good night.